Hi, I'm gonna tell you how to solve system of linear equations using Cramer's rule. First, let's check the equations. The equations for any system of linear equations could be of the form a sub 1, a sub 1, x sub 1 plus b sub 1, y sub 1 equal to c sub 1 and c sub 2, b sub 2 and a sub 2. And Cramer's rule is a way to do it using determinants. So you just have to define the following determinants. Use the following determinants. Which determinants we have to use? So first, we can use dx sorry dx dx okay, dx. And what is dx? Dx is the determinant that we can find checking the coefficients that aren't part of x. So b sub 1, c sub 1, b sub 2 and c sub 2. Okay, this is dx. It's a definition. dy oh, I'm sorry, dx, we gotta write c sub 1 first. We gotta write the c first, b and c. Now dx is like changing the coefficients here for the coefficients of z. And dy, so it's change the coefficients that are here for c. So a sub 1, a sub 2, c sub 1, c sub 2. And finally, we have d, determinant d. Determinant d are the coefficients a1, a sub 2, b sub 1 and b sub 2. Okay, if dx if dx equals 0, dy equals 0, and d equals 0, the system is the system is inconsistent. Excuse me, the system is dependent. If d if d equals 0, if d equals 0, the system is inconsistent. Okay, if d equals 0, the system is inconsistent, and if dx, dy, and d are 0, the system is dependent. And in other cases, we have that x is just the division of each determinant. So here is dx divided d, and y is d sub y divided d. This is why the system is inconsistent if d equals 0. If d equals 0, we have a division by 0, so system inconsistent. And if the three of them are equal to 0, it means that we cannot calculate x or y, so the system is dependent. We have the same line. Now let's see an example. Let's use it pretty quickly in an example. 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 Example 3x plus 1 plus 12y equals to 1, and 2 equals to 6y and x. Okay, so we're going to apply Cramer's rule to solve the system. So first, let's calculate dx, dy, and d. So c sub 1 here is 1, c sub 2, 2, x sub 1, 3, b sub 1, 12, b sub 2, 6, with y, a sub 1, 3, a sub 2, 1, c sub 1, c sub 2, 6, c sub 1, 12. Now finally d, 3, 1, 6, and 12. Okay, let me tell you something that I didn't write. This is a matrix, and we're not determining the matrix but the determinant of the matrix. Determinant of the matrix. Okay, and maybe you will be asking right now what a determinant if is. Okay, remember, a matrix is just an array of numbers. So we organize the numbers. And the determinant is an operation that we can perform with this matrix. For this type of matrices, 2 times 2, we just have to multiply the diagonals and subtract it. So which are the diagonals here? 1 and 6 and 2 and 12. So the determinant of this matrix is 1 times 6 minus 2 times 12. So in this case it's 6 minus 24. Dx is minus 18. Let's do the same with y. 3 times 6, 18, minus 1 times 12, 12. So we got 6. And let's do the same with this. 3 times 6, 18, minus 12. Let me see. I'm seeing a mistake here. It's here. Here is 1 and 2. Sorry. dy is a1, a2, 3, 1, c1, and c2. So d is 18 divided 12. That is 6. And here is 3 times 2, 6, minus 1. That is 5. So solution. The solution of the system. X is dx minus 18 divided d 6. So dx is x is 3 minus 3, and y, so x equal minus 3, and y equal to 5 divided 6. And this is the solution of the system. It's better that you check the system. Check the solution. Maybe we commit a mistake. Maybe you didn't check here properly as I did, and we commit a mistake. So always check the solution. We check the solution by using the original equation and changing the x for 3, and we gotta change y for 5, 6. Okay, it's not 3, it's minus 3. And here y for 5, 6. Okay, so 3 times minus 3, this is minus 9. 12 times 5, 6, we can simplify the 6 with the 12 to have 2, and 5 times 2 is 10. Minus 9 plus 10 equals 1. Yes, that's correct. Minus 3 plus, we can simplify 6 with the 6 here, and we just have 5. 5 minus 3 is 2. Yes. it is correct. So the solution of the system is x equal to -3 and y equals to 5/6. And this is how you apply the Cramer's rule. I hope that you enjoyed the video, and if you have any question, let me know. Thanks. Goodbye.